Hello lovely people. I wanted to do a video on motors and some of the software and calibration and setting them up. And lucky me, it's a great time to do them because I have a failed motor. And unfortunately, it's the coax one, which is one of the most difficult to change and replace. FYI, if you do need to replace any of these, it's a pain in the ass. You actually have to disassemble the whole body to get this out because you can't take any of these servos out without successively disassembling the others. So yes, the entire leg has to be taken off and disassembled. Luckily for me, this is the first motor to come off, so I won't have to take the whole leg apart. But I can tell you what happened here. So I decided to replace some of the plastic, one of the pieces being this rear end piece. And so, yes, I did have to disassemble all this. And while I was in there, I took off all four legs to tighten up all the joints. So there's my first advice to offer you all. So I am using metal, I'm assuming they're aluminum, servo horns. And in my 3D prints, I changed the original design, which used plastic ones, to accommodate these. Okay, so they're attached in there with 4 screws to their respective plastic counterpart. And then I use a standard, screw into the servo, but put a drop of Loctite on that, or thread lock, on those screws that go into the servo, into here, because those will loosen up on you, and then the legs get really shaky and really loose. I mean, this is about as good as you can get it. This is really the combination of the servo in there and this one. That's how much play we get. Okay, but had I shown this video before I fixed them, they were really, really loose from months of debugging and her falling over and jamming servos up, etc. They loosen up. So anyway, first advice, Loctite on your screws that attach the servo horn to the servo. Okay. Next, assembly and calibration. Very, very, very important. The first thing you do before you start assembling any of this is home all of your servos. So I picked up this servo tester, which you can plug in up to 6 servos at once, but there's really no need to do that in this case. But it's a pretty cool little device. I think it was like 25 bucks. You could easily put one together with an Arduino Nano and a potentiometer, basically, and a button. So the button homes the servo, right? And then the potentiometer, you can move it around. So the very, very first step, yes, is to turn that on and then home all of your servos. I have all 3 on this test leg connected right now. So I press the home buttons. So now all the servos are in their home position. And again, I should have done this before I assembled it, but I'm just demonstrating to you guys. And clearly, if I look out a little bit, I didn't quite home these before I put this test leg together. And again, that's okay because if it's a test leg. But here's my second piece of advice. Once all the servos are homed, okay, be very, very careful. You won't be able to move it when you're just playing with the servo itself. I mean, even if I tried, I can't turn that by hand. But once they're assembled, it's very easy to screw it up. So assemble it carefully, okay? But you have to do each leg symmetrically. So what I tended to do was keep these 2 pieces at a parallel, and then I would also keep these at a parallel. So I did all 4 legs the exact same way. And the way I made sure the leg was parallel is once it was assembled, I just placed it down and flattened it out like that. Obviously not to let the servo move before I connected the servo. And then drive the screw in there, tighten it up so it's nice and flat. And if you do all 4 like that, and then again with this, make sure these are parallel, and then how it joins into the body piece is parallel. So if you do all 4 like that with your servos homed, you'll be off to a great start. If you don't do that step, trust me, once you assemble it, if you're off a few degrees, you can make up for that in software. But any more than, I'm not even going to throw a number out there, but if you're off too much, you're going to have problems with software, or your numbers will just be too ugly to work with, and you'll end up disassembling all to realign your servos. Because let's face it too, you're not going to be perfect just because of the way these servo horns fit onto the gear. I mean, I couldn't tell you how many teeth are on this gear, but probably 32 maybe a few more. So you really only have every 5-degree increments as it is. So you're going to be a little off. but get as accurate as you can to make sure all 4 legs are assembled symmetrically the same with the homed servos. And then I would also suggest, before putting all this down completely together, turn on your servo checker again and home them all, and you should see them all nice and parallel like that. If anything's way out of whack, or you mess something up and put one on 180 degrees the other way, yeah, disassemble it now and fix it and put it back together. All right, so that's really the hardware side of calibrating servos. I'm going to next show you the software side, as well as explain more in detail how I blew this servo up, so that you hopefully don't do it yourself. Okay, so on the software side, this is a sketch that I wrote to do the calibration for the servos and the legs. I wrote it using some examples from Adafruit for their library for the PWM controller that I'm using. And there are 2 settings that gave me a whole lot of trouble and really are what I believe the cause of most of my servo burnouts. They are oscillator frequency and the PWM frequency. I cannot explain to you what either are. I don't know myself, and that's pretty much why I had problems with them. I just know that if you change either one of these, all of any numbers that you have or any calibration you've done or how you think this leg is going to move goes out the window. It takes on a whole new meaning, whole new life. Obviously, it's because you're changing the frequency of the pulse or the oscillator, so it's going to change the quote-unquote speed, or I couldn't really tell you, like I said. But that, if anybody knows, I'd love to hear in the comments, and then I'll explain it better in my next video. I just haven't bothered to research it, though I probably should have, because it probably cost me a few dollars in burned servos. That being said, Adafruit did suggest 50 hertz for analog servos, but I'm pretty sure that these are digital servos. I mean, it does say digital servo on it, so I don't really know what the difference is again. And I think at one point I read somewhere in their forum that somebody was using 60 hertz, so I went ahead and adjusted that, and I think the frequency also was defaulted at 27, is that million? Yes, 27 million. Again, I took these settings from somewhere in their forum, and it worked well for these servos, so I stuck with it. But, for example, the reason why I just explained, you can't see this leg in this video, but this back motor that is now burnt, it's because I used this calibration script that I have here on the smaller SG90 servos on another project that I'm working on, and I had changed this to 50. And then I went and plugged her back in, and her legs all just went whoop, all in crazy yoga positions on startup. And yeah, I probably didn't realize it fast enough, but luckily I caught it before I burned out more than one servo. So I just want everybody who uses this or any of these PWM controller boards, I'm sure, have these settings. Be very, very careful about that. And you're better off only plugging in one servo at a time until you get your settings correct. Now, another word of caution regarding that. So I've had her running on her software, right? So all of the motors are energized. Even if I fire this script now, which is only setting up one leg, 3 servos, all of the other ones are still energized and still in their holding position. So if you shouldn't test like that, in my opinion. So you really need to power down the robot completely, not just kill the battery power, the motor power, but disconnect the Arduino as well, because that's what's remembering these servos are powered up and they're going to stay powered up. I believe you can do it in software with Adafruit's library, but I did not bother. So yes, word of caution. When you're going to test another servo after you've finished one, completely power everything down, including Arduino, and then they'll all go back to not being powered up. And then you'll see when you start it up, just that one that you defined to start will. Okay? So that's very, very important. So anyway, I don't want this video to run into an hour like some of mine are starting to be pretty long. So let me continue here. So this is a really, really simple script. Again, Adafruit will suggest to you that when you're calibrating, all servos vary their pulse timing. So you have to do this very carefully. In their example code, they started off at like 300 as the home for the PWM. And then I just added 50 and subtracted 50 from my min and max and just went from there and worked out in increments of, whatever I felt. Obviously, the servos can do 270 degrees, but you have to take in consideration this is going to head into here, so you have a lot of other mechanical constraints as far as the design of this robot. But once you figure out the max for each of the three motors, min and max, or I should say, let me rephrase that. The first thing you want to figure out is the home. So if we go look at the spreadsheet that you just saw quickly, so I put together the spreadsheet where the first thing I did was figure out my home positions. Now you remember I said when you assemble them, I went ahead and made the leg perfectly perpendicular so that I didn't have to match this angle across all four. Ideally, yes, if you can match these angles and assemble all four of them like that, more power to you, go for it. But I decided to do it all parallel so that they'd be perfect. So then in the software, I adjusted my home position. What's this, 35, 40 degrees off? So in software, this is my home position. Okay, but hardware-wise, yes, my home servo positions are parallel legs. Okay, so that's the first thing is you want to get the home positions for all 12 of your motors. And I'll put this spreadsheet up on my GitHub too in case anybody wants it because it is pretty handy. Once I plugged in all of those home positions, then I just did one leg, the coax, the femur, and the tibia joints to figure out their min and max movement. Again, not just the servos, but the mechanical constraints as well. Okay, and the coax you have the most restriction in. So if we look at my spreadsheet here, it only travels 120 PWM, whereas the femur and tibia travel twice that. Okay, so anyway, yes, once you figure out your min and max for one leg, then this spreadsheet, all these numbers here are calculated by the spreadsheet. So then it gives me the center point between that, tells me the total travel, the minimum travel, the maximum travel, and then center min, center max. And once I had those numbers there for each joint for the one leg, then I adjusted these min and max numbers for the rest of the motors according to make these numbers match. So you'll see that all the coaxes travel 120 PWM and they all have the same min max. Now, yes, left and right legs, don't forget, are going to be opposite integers. So you'll have negative and positive, whereas on the left leg will be positive and negative. That can be a little tricky in software. I've seen it handled a few different ways, so you'll see how I did it and do as you wish, how you want. I'm sure mine is long-winded because I've mentioned this before. I'm a web programmer, not a C programmer, so a little bit of a different world when it comes to us. We're not so concerned with if statements as C programmers are. Anyhow, I digress as I often do. So once you have all the numbers matched up, and this was pretty ironic how it came off 113 across the board. So yeah, once you've adjusted all of your min and max numbers so that all these numbers come out uniform, then you're good to go. So now everything's calibrated properly. And just to finish talking about the spreadsheet, so this ID is just the numbers pertaining to here. This pin number is the PWM pin number. Now it has 16 channels, so 16 pins, and as you all know, things go by 0. So I decided to use the banks of 4 pins and just leave the end one empty. So that's why the numbers are not quite sequential. They're missing one in between, just to explain that. And then I assigned each motor a name, which is right front coax, right front femur, right front tibia, so on. And then right rear, etc. Okay, and that all pertains to the software. So just to finish this discussion, so then I took these numbers here in this block, and those get plugged into the software Well, that's the calibration script. Well, yeah, they get used here too as well. So then this calibration, I just do one leg at a time, and they have two settings for each motor. The coax, femur, and tibia, you can either set them to just home position, or you could set them to run, which will basically sweep between their min and max. So the first thing I do is set them all to their home positions, and then upload the script, which I can do now while we're talking here. And they're already homed, and like I said, mine are all energized right now too, so I don't suggest doing that when you're testing for the first time. So they've all homed, so nothing exciting happened. But if I go ahead and set this one to number 2 now, which tells it to run the femur, now it'll sweep that one motor. And basically, yeah, you just run a script like this that'll sweep through a motor for you like that, and you just gradually adjust the minimum and maximum until, again, you've reached not only the servo constraints, but your hardware constraints. Okay, so that's really it when it comes to calibrating. Yeah, one thing I should talk about, and I can't really talk about much, let me stop her, because again, I'm not a physics scientist, is center of gravity. So very, 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 very important when it comes to walking gaits, as I learned the hard way. So I didn't know anything about that, didn't realize it was going to be that much of a problem. I mean, I assumed also that the plastic was designed by the original gentleman who put it together to be pretty symmetrical, and it is. But once you start putting electronics and batteries, etc., yeah, that plays a major role in your center of gravity. And that's very important for, okay, if you're going to lift each foot off the ground by, let's say, an inch, if you're back heavy, that's not going to work. Your foot's not going to come up an inch because it's got so much more weight to lift up, right? That's the generic physics behind it, I guess. So it's very important to get the center of gravity right. So I had a major problem where she was very, very back heavy when I first put her together. So anytime I tried to just do a rudimentary walking pattern, she just dragged her back feet and sometimes could not even move forward because of it. So I, in software, adjusted the front legs to move a little further as their home positions, which moved the center of gravity and took some of the load off of the back. But it still is back heavy. So I tried to adjust it in software even further so that anytime she was doing a walking motion, she would, apply a weight factor to these back legs and actually lift them further than she was lifting her front legs to compensate for the weight difference. Yeah, I gave up on that. Bad way to go about it. So I am still torn on how I'm going to get her center of gravity right. If I'm going to, again, try and adjust the legs to get it, or if I'm going to try and move around some of my hardware, or I'm not even sure what else can be done besides redesigning. Maybe these shoulder joints are not in the right positions as far as the whole model is concerned. So maybe there has to be some adjustments done to the framework of the PLA prints. I really don't want to reprint all this because that was the long, excruciating part of this whole project. The not so fun part, waiting for prints to finish, as you'll all find out or already know. Yeah, so anyway, center of gravity, very important. Research it. Do your best to try and keep that in mind as you're building, as you're placing electronics, where you place your battery, etc. How to test for center of gravity, I really couldn't tell you. I mean, I'm assuming it's just kind of balancing on a broomstick kind of thing and see where, she moves and balances best. So as you can see, well, you can't really see, but my hand is a good ½ inch more towards the back than the center. And she's still leaning back. So I'm still back heavy. All right, so that's all I can tell you about center of gravity. Very important, though, to get that done before you... I still have not really been able to do a successful walking gait that I'm happy with. You see in some of the videos that I have her trotting along, you can see her back legs just dragging on the ground, and that's why. What else? I think this is probably a good place to wrap. Just real quick, so then in the main software... I haven't released this to anybody yet. If you guys are looking to use it, I know some of you have asked. I will be, but I had mentioned in my software review video that I had a whole test routines in here to test all the movements. I tore all of that out. So now you'll just see a few debug statements here where you can set which leg, which servo, how many times to loop, and then a speed. And I decided to plug in all the testing. Let me upload this while we talk. I decided to move all of the test loops into my serial command. So I have a script way down here somewhere. Right here. So it basically just monitors the serial terminal where you can type in a character and then it'll execute one of the moves. So I moved all the debugging stuff into here. But as I did that, also I put in a little code to test in each individual servo as well as an entire leg at once. So once this boots up here, I'll show you. Okay, so it says, well, you can't see that really with the video over it, sorry, but it says press H for help. So if I press H, now you get the whole schedule of commands that I have in there. One character command, so if I hit M, she'll start marching. Okay? And yeah, so you can see down here at the end, I have the debug servo right now is set to 0, but then there's 2 keys you can hit to toggle through the 12 servos. So you could choose whichever one you want. And then the same with the legs, there's one key to toggle through the 4 legs. Okay, and then if I hit G, it'll test that single servo. Oops, it's hitting the wall. Sorry about that. And if I hit E, it'll test the whole leg. Now, be very careful when you do something like this, because moving all 3 servos at once, you need serious clearance. If I move the back leg in this same pattern, it would collapse into the front leg and cause a problem. In here. Okay, and then I could cycle through and choose a different leg or a different servo. So I've moved a lot of the test script out of the code and it cleaned it up a little bit. Okay guys, so that's all I have for you today. This is probably an hour-long video at this point. I still said I was going to do a video on the actual motor class, which really is the soup and nuts and bolts of this whole thing, so we will do that next time. All right, thanks for watching.